So in this video we're going to introduce multiplication with fractions on the Roman abacus and counting board, and we're going to use some techniques we've been experimenting with in the Reading Ancient Schoolroom. This video presupposes the information in our videos called Introduction to the Roman Abacus and Counting Board, Multiplication on the Roman Abacus and Counting Board, Division on the Roman Abacus and Counting Board, Introduction to Fractions on the Roman Abacus and Counting Board, and Division with Fractions on the Roman Abacus and Counting Board. So you might like to watch those videos first. We're not going to introduce too many new techniques in this video because multiplication with fractions on the Roman Abacus and Counting Board mostly uses techniques we've already been using. So this will be mainly a revision video. Now suppose we wanted to multiply 492 by 5/12. Eleanor, could you write a 492 and then a 5/12 symbol in Roman numerals and symbols?
That's the 400. That's the 90. That's the 2.
Excellent.
And that's the 5/12.
Excellent. 5/12 is a quincunx and it's written with 5 dots like that. Now asking what's 492 times 5/12 is the same as asking what's 5/12 of 492, and that's the same as asking what's a 12th of 492 times 5. And to find out, we can divide 492 by 12 and then multiply the answer by 5. Now to do division, we've been using 2 counting boards, or we could use 2 abacuses, but what we've got here are 2 counting boards. Eleanor, could you enter a 492 on the top counting board?
That's the 400. That's the 90. And that's the 2.
Excellent. And could you divide that by 12 in the way that we've been doing division?
So to divide by 12, we need to find things that look like a 12, and that looks like a 12, but it's shifted one place to the left. So it's 10 times 12. So we take that off and put a beam under a 10.
Great.
And then we can do that a second time.
Great.
And in order to do it a third time, we have the 100 fine, but we're going to have to take the 20 out of the 50, and 50 minus 20 is 30. And now we can do it again. And then we have an actual 12 not shifted to the left. So that does that.
Great, so that's your 492 divided by 12, but what we wanted was that number now multiplied by 5 to give us 492 times 5/12. We can do multiplication on a single counting board. Could you multiply that number by 5?
So if I'm going to multiply one of these by 5, I'd move it up. But of course when you move up 2 50s, what you get is 100. And then you do that a second time, and then this one can simply be moved up and it stays.
Great, and that's your answer. And what's that number?
205.
Great. Now I gave you an easy one because no fraction appears in the answer, and of course that won't always happen. Let's do a slightly different one. Let's do 494 times 5/12. Could you adjust your wax tablet so that that first number says 494? Great, so we're going to multiply 494 by 5/12, and we're going to do it in the way that we've just done. Would you like to enter a 494 on the top counting board?
400. 90. 4.
Great, and would you like to divide that by 12? Great, so that's your 494 divided by 12. You've got a remainder of 2 there. And one thing that Romans might do when they get to this point is say, we're just going to ignore that remainder. If we think of dividing that by 12, that will be a small number when we've divided it by 12. Perhaps we don't need to bother too much about that. We could carry on and multiply this by 5. And there's some evidence that they sometimes did that, if they didn't care about getting the answer completely accurate. But if we want to be as accurate as we can, we need now to divide that remainder by 12 as well. How are you going to divide that remainder by 12?
Well, I can't use the system that we were using before because the ratios between the columns are not the same.
Right.
But conveniently, this next column, instead of being tenths, is twelfths, and we're dividing by 12, so 2 divided by 12 is 2 twelfths.
Excellent, yes, so we've got to be a bit careful when we move from whole numbers to fractions because things work a bit differently when we're in the fractions area of the counting board, but indeed 2 divided by 12 will be 2 twelfths. Excellent, and now we wanted to multiply this by 5. Can you multiply that by 5?
So these two, 100, these two make a second 100, that makes a 5. And here again, because the ratios are different, I can't simply move it up.
Great.
But I happen to know that 2 multiplied by 5 is 10. So 2 twelfths multiplied by 5 will be 10 twelfths.
Excellent, yes, so again we've got to be a little bit careful when we're in the fractions area. When we've been doing whole numbers, we've been saying if you want to multiply anything by 5, then you can move it up to the top of the counting board. That won't work over here with the fractions, but it's convenient to know that 2 times 5 is 10, and therefore 2 twelfths times 5 is 10 twelfths. Excellent, and that's your answer, and what's that number?
205 and 10 twelfths.
Excellent, and for good measure, shall we do a sum where there's a fraction in both the numbers that we're multiplying by each other? This might not happen as much in real life, but let's do 2 and 2 twelfths times 5 and 7 twelfths. Would you like to write, first of all, 2 and 2 twelfths? Excellent, and would you like to write 5 and 7 twelfths? Excellent. Now, when we've been multiplying on the Roman abacus or the counting board, we've been taking one of the numbers we want to multiply. Let's suppose we take the 2 and 2 twelfths, and we've been multiplying it by each digit of the second number individually. And I suggest we take the 5 as one digit, the Roman V, and the 7 twelfths as the second digit. So what we're going to do is we're going to take 2 twelfths, and we're first going to multiply that by...
You mean 2 and 2 twelfths?
Sorry, we're going to take 2 and 2 twelfths, and we're going to first multiply that by 5, and then we're going to take 2 and 2 twelfths and multiply that by 7 twelfths, and in the end what we want is to add those two things together. Anna, would you like to enter 2 and 2 twelfths on the top counting board?
So that's the 2. And that's the 2 twelfths.
Excellent. Now we don't really want 2 and 2 twelfths on that counting board. I just wanted to think about what that looks like. What we want to start with is that number 2 and 2 twelfths times 5. Could you multiply that by 5?
So each of these multiplied by 5 moves up, but you can't have 2 5s, so that's a 10. And as we had just observed, 2 twelfths multiplied by 5 is 10 twelfths.
Excellent, so that's the 2 and 2 twelfths times 5. We now want 2 and 2 twelfths times 7 twelfths. And to do 2 and 2 twelfths times 7 twelfths, we're going to take 2 and 2 twelfths and first divide that by 12 and then multiply by 7. Now we've been doing division on 2 counting boards, but we've already got some beans on this counting board that we don't really want to get in the way of. So I suggest what we do is just think about what 2 and 2 twelfths looks like on a counting board. Have that on a counting board in your head, as it were, and divide that by 12 and enter your answer on here.
So the 2 divided by 12 is relatively simple. That's 2/12.
Great.
Then we've got the 2/12 divided by 12, which is a little scarier because of the ratios being all different here. But 2/12 is really the same thing as 1/6. And if you divide that, you're going to end up with this. Am I right?
Yes. Now, one way to think about that, which we did in our Introduction to Division with Fractions video, is to think in terms of how many 12th parts of a 12th you can have in each of these boxes. In this box, if you have a bean, that's 6/12 parts of a 12th, otherwise known as half a 12th. In this box, you can have 3/12 parts of a 12th, otherwise known as a quarter of a 12th. In this one, if you have one bean, that's 2/12 parts of a 12th, otherwise known as a sixth of a 12th, or if you have two beans there, you'd have 4/12 parts of a 12th. And because that's 2/12 parts of a 12th, indeed, if you've got 2/12ths and you divide that by 12, then one bean there is exactly what you get. Excellent. So that's your 2 2/12 divided by 12, but we also now want to multiply that by 7. Could you multiply that by 7, keeping it on the bottom counting board?
So we can't really use quite the same kind of multiplication we would have done before, multiply by v and then by I and then by I, because again the ratios are a little different in the fractions. But I happen to know that 2 times 7 is 14. Therefore 2/12 multiplied by 7 will be 14/12, and 14/12 is 1 2/12.
Great.
And then for this, if I multiply it by 6, I'm then going to get this. Am I right? Or am I going to get this?
Which one do you think?
Maybe this. Okay.
So this is a 12th. What you had
That
here
was a
was
sixth
a
of a
6th of a 12th. Good.
But I want to multiply it by 7, not just 6. So then I put another one there.
Excellent. So that's your 2 2/12 times 7/12, and we want to add that number now to your 2 2/12 times 5. Can you add that number to the top counting board?
The 1 goes up quite easily, and this is already 10/12, so that makes 11/12. And this one is going to make 12/12, which is actually 1. So we take those all away, and then the last 1/12 and becomes another 12, and that becomes a 72nd.
Excellent. And that's your answer. And what's that number?
12 and 1/12 and 1/72.
Excellent. And that brings us to the end of this video. This is who we are. Thank you for watching.